Hello students, I am Swarnlata Sharma from KV Muradabad. In our previous sessions, we have studied about trigonometry, angle measures and signs of trigonometric ratios in different quadrants. Now, we shall solve some problems using signs of trigonometric ratios in different quadrants. Find the values of cos theta and tan theta if sin theta is equal to minus 3 upon 5 and theta lies between pi and 3 pi by 2. Solution: we have cos square theta plus sin square theta is equal to 1. Now, in the third quadrant, how I could guess it is third quadrant? Because theta is lying between pi and 3 pi by 2. So, in third quadrant cos theta is negative and tan theta is positive. Therefore, cos theta is equal to minus root of 1 minus sin square theta, that is equal to cos theta is equal to minus root of 1 minus 9 upon 25, which on simplification gives minus 4 upon 5. Tan theta is equal to sin theta upon cos theta and can be simplified as minus 3 upon 5 into minus 5 upon 4, that is 3 upon 4. Let us take one more example. Find the value of sin 31 pi upon 3. Solution: we know that values of sin x repeats after an interval of 2 pi. Therefore, sin 31 pi upon 3 can be written as sin 10 pi plus pi by 3, which is equal to sin pi by 3 and its value is root 3 upon 2. One more example, find the value of cos minus 1710 degrees. Solution: we know that values of cos x repeats after an interval of 2 pi or 360 degrees. Therefore, cos of minus 1710 degrees can be written as cos minus 1710 plus 1800. This on simplification gives us cos 90 degrees, that is obviously 0. Now, let us study about the domain of trigonometric functions. We know that sin x and cos x are defined for all real values of x. Tan x and sec x are defined for all real values of x except when x is equal to 2n plus 1 into pi by 2, where n is an integer. Cot x and cosec x are defined for all real values of x except when x is equal to n pi, where n is an integer. We can summarize this in the form of a table with functions in one column and domain in another column. Sin and cos have domain as all the real numbers. Tan and sec have domain as all the real numbers other than 2n plus 1 into pi by 2, where n belongs to integers. Cot and cosec have their domain as all real numbers other than n pi, where n belongs to integers. Now, let us see the range of trigonometric functions. As minus 1 is less than equal to a is less than equal to 1 and minus 1 is less than equal to b less than equal to 1, in unit circle cos x will lie between minus 1 and 1 and sin x also will lie between minus 1 and 1, that is minus 1 less than equal to sin x less than equal to 1. Thus, the maximum and minimum values of sin x and cos x are 1 and minus 1 respectively. Since tan x is equal to b upon a and cot x is equal to a upon b and any of a and b can be greater than The other, tan x and cot x, can take any real value. Now, minus 1 is less than equal to a less than equal to 1, where a is not equal to 0 implies 1 upon a is greater than or equal to 1, or 1 upon a is less than or equal to minus 1. That implies sec x is greater than or equal to 1, or sec x is less than or equal to minus 1. Also, minus 1 is less than or equal to b less than or equal to 1, where b is not equal to 0, 1 upon b is greater than or equal to 1, or 1 upon b is less than or equal to minus 1. This implies cosec x is greater than or equal to 1, or cosec x is less than or equal to minus 1. This can be summarized as function with their range. Sin, cos have their range as minus 1 and 1. Tan and cot have range as any real value. Sec and cosec have range as any real value except minus 1 and 1. Now, let us study about periodic functions. What is a periodic function? A function f of x is said to be a periodic function if there exists a real number t greater than 0 such that f of x plus t is equal to f of x for all x. Since sin of 2 n pi plus theta is equal to sin theta, cos of 2 n pi plus theta is equal to cos theta for all values of theta and n belongs to n, therefore, sine and cosine functions are periodic functions. We find that 2 pi is smallest positive real number such that sine of 2 pi plus theta is equal to sin theta, cos of 2 pi plus theta is equal to cos theta for all the values of theta. So, sine and cosine functions are periodic with period 2 pi. We also know that tan of pi plus theta is equal to tan theta and cot of pi plus theta is equal to cot theta. Therefore, tan theta and cot theta are periodic with period pi. Similarly, cosec theta and sec theta are periodic functions with period 2 pi. Now, students, do you know what are even and odd functions? Let us see what are they. A function f of x is said to be an even function if f of minus x is equal to f of x for all x in its domain. A function f of x is an odd function if f of minus x is equal to minus of f of x for all x in its domain. We have seen that sin of minus theta is equal to minus sin theta, cos of minus theta is equal to minus cos theta and tan of minus theta is equal to minus tan theta. Therefore, sin theta, tan theta and their reciprocals cosec theta and cot theta are odd functions, whereas cos theta and its reciprocal sec theta are even functions. Now, students, let us solve some interesting questions. If a cos theta plus b sin theta is equal to x and a sin theta minus b cos theta is equal to y, prove that a square plus b square is equal to x square plus y square. Let us take LHS as x square plus y square and simplify. A cos theta plus b sin theta whole square plus a sin theta minus b cos theta whole square can be expanded as a square cos square theta plus b square sin square theta plus 2ab cos theta sin theta plus a square sin square theta plus b square cos square theta minus 2ab sin theta cos theta. Here we have used two identities. A plus b whole square is equal to a square plus b square plus 2ab and a minus b whole square is equal to a square plus b square minus 2ab. Here minus 2ab sin theta cos theta gets cancelled with plus 2ab cos theta sin theta, and we have common terms as a square and b square. Look here, a square if you take common, we get cos square theta plus sin square theta, plus b square is common again, sin square theta plus cos square theta. This can be written as a square plus b square, as cos square theta plus sin square theta is 1. Let us take up one more example. If a cos theta minus b sin theta is equal to c, show that a sin theta plus b cos theta is equal to plus or minus square root of a square plus b square minus c square. Let us see to the solution. We have a cos theta minus b sin theta whole square plus a sin theta plus b cos theta whole square. Again using the identity a minus b whole square, we have a square into cos square theta plus sin square theta plus b square into sin square theta plus cos square theta minus 2ab sin theta cos theta plus 2ab sin theta cos theta. They get cancelled here with opposite polarity. Therefore, we have a square plus b square, as cos square theta plus sin square theta is 1. Therefore, a sin theta plus b cos theta whole square is a square plus b square minus a cos theta minus b sin theta whole square, which implies a sin theta plus b cos theta whole square is equal to a square plus b square minus c square. That is, a sin theta plus b cos theta is equal to plus or minus square root of a square plus b square minus c square. Here is an interesting identity which appears in exams many times. Sin theta plus cosec theta whole square plus cos theta plus sec theta whole square is equal to tan square theta plus cot square theta plus 7. Let us take LHS. Sin theta plus cosec theta whole square plus cos theta plus sec theta whole square can be expanded as sin square theta plus cosec square theta plus 2 sin theta cosec theta plus cos square theta plus sec square theta plus 2 cos theta into sec theta. Here, what is sin square theta plus cos square theta? It can be written as 1. Now, cosec square theta can be written as 1 plus cot square theta, sec square theta can be written as 1 plus tan square theta, and two expressions 2 sin theta into cosec theta. This can be solved as 2 sin theta into 1 upon sin theta. So, sin theta get cancelled. Similarly, in the next expression 2 into cos theta into sec theta, cos and 1 upon cos theta gets cancelled, and we have 1 plus cot square theta plus 1 plus tan square theta plus 2 plus 2, which on solving gives us cot square theta plus tan square theta plus 7, that is equal to RHS. Hence, we have proved the identity. So, students, today we have studied about periodic functions, even functions, odd functions, domain of trigonometric functions, range of trigonometric functions, and in the next session we shall study about the graphs of trigonometric functions. Thank you.